When you have increased amounts of evaporation, you're going to have lots of rain in some places and not in others. We're going to talk about that when it comes to the state of Texas. What we're experiencing here in Houston is a perfect example. Harvey and then the great drought of 2014. We've got changes in our snowpack in the western United States where we're just not getting the snow we were getting before. Fluctuating drought conditions interspersed with fluctuating precipitation. We've got this dramatic decrease in Arctic sea ice, and we're going to talk about why the Arctic is particularly vulnerable to climate change in a minute. We've got increasing U.S. sea levels. That is just not debatable. There are places like Miami that are actually having to figure out what they're going to do on their coastline because of rising sea level. Marine species distribution changes. Ocean acidity, as we increase the amount of carbon dioxide in the atmosphere, the carbon dioxide goes into the water and creates ocean acidity. Changes in growing seasons. Agriculture is changing. We're getting warmer and warmer temperatures, more and more drought, and so that's changing how we grow crops in the U.S. Wildfires, that's another big indicator of drought. Acres burned, wildfires fluctuating all over the world. And then heating days and cooling days. What that means is how often we run our air conditioners is here, and how often and that's going up, and how often we run our heaters is going down. Now, let's look at kind of climate change indicators, right? So snowpack, drought, heavy precipitation, heat waves, temperature. So these are all of these aspects, growing season, these are all indicators that something is going on with our climate. So if you want a go-to place of why scientists are worried, they see all of this happening today, this is a great place to go for all of kind of the information about that. Now I'm going to kind of pull some interesting details out from this infographic. One is I'm going to go here to this temperature plot. It turns out that when we talk about changing temperatures, so the average temperature is going up, it turns out that the Arctic changes in temperature are greater than anywhere else on the planet. And you need to know the reason for that. And the reason for that is this, called the albedo effect. You know, when you've got a glacier on the surface, and this could happen on the sea, could be sea ice or it could be land ice. When you have this, the sun, 85 to 90% of it hits that glacier or that ice or that snowpack, and it's reflected like a mirror back into outer space, and only some of it's absorbed. But if that ice melts because of increasing global temperatures, then all of a sudden 70% is absorbed. So the temperature is changing wildly in the Arctic and the North and South Poles because they have two things happening. One, the temperature's going up, and two, they're losing all of this ice pack and ice melt. So if you look, this is a picture of Greenland area where you had ice pack all the way down here, almost the whole ocean. It's considerably retreated because of increasing and warming temperatures. Now I want to mention one thing here when it comes to sea level rise. So we often think, oh, the reason the sea level is rising is because there's ice melting, and so that's making there be more water in the oceans. And that's sort of a misconception in that if it's sea ice, we know from putting ice cubes in a glass of water, if we put a bunch of ice in a glass of water and the ice melts, the water doesn't overflow in the glass. Because ice is actually less dense than water, and when it melts, it doesn't take up more volume. That's not the part that's causing the sea level rise. Sea level rise is really caused by a little bit of land ice. So now if land ice, like glaciers, melt, that water is going into the oceans. But that's not even the primary source of sea level rise. Sea level rise is coming primarily from thermal expansion of the water. We know from chemistry and physics that when you heat something up, the atoms and molecules are moving faster and taking up more space. And that causes, if you look at this, the actual level of the water, the depth to land, to increase by these small changes in temperature, because the oceans are literally expanding. And that's really the primary reason we have sea level rise. So we've got, the Arctic is experiencing very difficult times because of this global changing climate, and our oceans also are expanding. Also in the oceans, we have another problem, and that's ocean acidification. What happens is carbon dioxide in the atmosphere, we have this equilibrium. Remember that carbon dioxide is the oceans are a reservoir, aren't they? So the reservoirs for the carbon cycle are the soil, plants, the atmosphere, and oceans. Those are the big ones, right? And the ocean absorbs enormous amounts of carbon dioxide. And when it does, it makes a little bit of carbonic acid, which is a weak acid. The problem is we're putting more carbon dioxide into the atmosphere, and when that happens, we are actually lowering the pH of the ocean. So if you start at an ocean pH of about 8.2, this is a specimen of I don't know how to say that, but it's a shell crustacean, a shelled animal, I should say, in the Central Pacific. You can look at their mean shell thickness, and when you just drop a tenth, now remember that we're on a logarithmic scale here, so a drop of a tenth of a point in pH is actually a 30% increase in acidity. You can see for atmospheric CO2, we were at 280. We're up at 400 now. We have almost doubled. No, not quite. I would say we've increased our carbon dioxide concentration in the atmosphere by about 2/3 probably. So here we are, 2011 at 400. We're now, I believe, at like 410. But the shells are thinning because this is an acid, shells are a base. Acid reacts with base to make water and salt, and so it's dissolving the shells of these animals. So what are the impacts? Rising sea levels, alteration of ocean currents and wind, melting of the ice caps. We're going to talk about positive and negative feedback loops on Friday. Coastal flooding, forest fires, grassland dust bowls, loss of food production, increased frequency and severity of storms, hurricanes, cyclones, thunderstorms, tornadoes. Spread of infectious disease, we talked about that, right? So like if you have an organism like a mosquito that lives near the equator, as we warm the planet, that will increase the vector of that insect, and ecosystem collapse. This is an interesting idea. We talk about these very, very small increments in temperature, right? So we are headed to 450. We'll be there soon. And that will lead us to about a 2-degree increase in average global temperatures. And here we are. Deserts will spread, conflict over water supplies. Because in some places you're going to have lots of water, too much water, other places not enough. Sea level rise enough to flood low-lying coastal areas such as Bangladesh. More people exposed to malaria. High risk of extinction for Arctic species such as the polar bear. Did you know that polar bears require the ice sheet in order to live? The only way that they can find their favorite food or hunt for it, seals, is when there's ice. Because what they do is they wait for the seals to come up for a breath, and that's when they get them. When there's no ice pack, they starve. Huge problem. Now when we go up here, when we go up to about 4 degrees, we're talking about all kinds of melting. I didn't mention permafrost. I want to do that now. In the Arctic, one of the other problems we have is that in places where there's a lot of decomposition in the soil, like a wetland or something like that, and that wetland's been frozen, and in the Arctic it's been frozen for a really long time, When you warm that land and that bog becomes, warmer, remember that decomposition causes methane to form. And so these permafrosts are thawing and releasing enormous amounts of methane into the atmosphere. And remember, methane is a much more difficult, or I would say affecting greenhouse gas than carbon dioxide. So you can see that small changes cause problems. So what I'm going to do next is talk about solutions. The solutions are pretty straightforward. I think what we'll do is we'll stop here and we'll do this on the next video.